NENOMATICA, where mathematics meets YouTube excellence. Today we'll explore how to rewrite different types of inequality expressions in their equivalent forms. Let's start by understanding the basic inequality symbols. We have four main inequality symbols. Less than, represented by a, is less than b, greater than, represented by a, is greater than b, less than or equal to, represented by a, is less than or equal to b, and greater than or equal to, represented by a, is greater than or equal to b. It's important to note that these symbols help us express relationships between values where they're not necessarily equal. Now, let's look at an example of how to express inequalities in their equivalent forms. The first rule we'll look at is, a is less than or equal to b can be written as a is less than b or a equals b. This can be written using mathematical notation as, a is less than or equal to b if, and only if a is less than b or a equals b. Similarly, we have the rule for greater than or equal to. A is greater than or equal to b can be written as a is greater than b or a equals b. Mathematically, a is greater than or equal to b if, and only if a is greater than b or a equals b. There's also an alternative way to express a is greater than or equal to b. We can say its equivalent to b is less than or equal to a. Mathematically, this is written as, a is greater than or equal to b if, and only if b is less than or equal to a. Now, let's work through a quick challenge. Let's verify one of these rules with a specific example. Consider the inequality. 5 is greater than or equal to 2. This is true because 5 is greater than 2. Using our rule that it is greater than or equal to b if, and only if it is greater than b or equals b, we can check, is 5 greater than 2? Yes, 5 is greater than 2. Is 5 equal to 2? No, 5 is not equal to 2. Since at least one of these conditions is true, 5 is greater than 2, the original statement, 5 is greater than or equal to 2, is true. Let's look at some more examples of inequality symbols. We have the equal sign, represented by the equals symbol, and the not equal sign, represented by the not equals symbol. For example, 1 plus 1 equals 2 is true, and 1 plus 1 not equals 1 is also true. Now, let's look at some examples with greater than and less than symbols. For example, 5 is greater than 2 is true, and 7 is less than 9 is also true. Finally, let's look at examples of greater than or equal to and less than or equal to symbols. For example, 1 is greater than or equal to 1 is true because 1 equals 1, and 3 is less than or equal to 3 is also true because 3 equals 3. Let's summarize what we've learned about inequalities. A is less than or equal to b is equivalent to a is less than b or a equals b. A is greater than or equal to b is equivalent to a is greater than b or a equals b. A is greater than or equal to b is also equivalent to b is less than or equal to a. Understanding these equivalent forms helps us manipulate and solve inequality problems more effectively. Let's start with our first example. For watching a film, you must be at least 13 years old. Let's write this as an inequality. If we represent your age as age, then we can say age must be greater than or equal to 13. This gives us the inequality. Age is greater than or equal to 13. Let's understand what this inequality means. The symbol greater than or equal to means that age can be exactly 13, or any number larger than 13. For example, 13, 14, 15, and so on are all valid ages for watching the film. We can visualize this on a number line where we include 13 and all points to the right. Now, let's look at our second example. For attending a painting class, your age must be less than 12 years. If we represent your age as age, then we need age to be less than 12. This gives us the inequality. Age is less than 12. Let's understand this inequality. The symbol less than means that age must be strictly less than 12. For example, 11, 10, 9, and so on are all valid ages for the painting class, but 12 is not allowed. On a number line, we include all points to the left of 12, but not 12 itself. Let's look at our third example. The maximum number of passengers that a bus can accommodate is 40 people. The word maximum means that the number of passengers must be at most 40. This means the bus can have less than 40 passengers or exactly 40 passengers, but not more. If we represent the number of passengers as n, then we have the inequality. N is less than or equal to 40. Let's visualize this with a simple diagram. Here's our bus, which has a maximum capacity of 40 passengers. It can accommodate anywhere from 0 to 40 passengers, but not 41 or more. On a number line, we include all points from 0 up to and including 40. Let's move to our fourth example. To advance to the next stage of a competition, you must have at least 50 points. The phrase, at least, means that you need 50 or more points to advance. This means your score can be exactly 50 or it can be higher than 50. If we represent your score as S, then we have the inequality. S is greater than or equal to 50. Let's visualize this with a scoreboard. Here's a scoreboard showing various scores. Scores of 50 and above are valid for advancing to the next stage. Scores below 50 are not sufficient for advancement. On a number line, we include the point 50 and all points to the right. Let's examine our final example. The maximum allowed weight in an elevator is 500 kilograms. The word maximum indicates that the weight must not exceed 500 kilograms. This means the weight can be less than 500 kilograms or exactly 500 kilograms, but not more. If we represent the weight as weight measured in kilograms, we get the inequality. Weight is less than or equal to 500 kilograms. Let's visualize this with an elevator diagram. Here's our elevator with its weight limit. The elevator can safely carry weights up to 500 kilograms. Any weight above 500 kilograms would exceed the safe limit. On a number line, we include all points from 0 up to and including 500. Let's summarize the inequality symbols we've learned today. The less than symbol, written as the less than sign, means strictly less than a value. The less than or equal to symbol means less than or equal to a value. The greater than symbol means strictly greater than a value. And the greater than or equal to symbol means greater than or equal to a value. We've seen these symbols in action through our examples. Age greater than or equal to 13 for watching a film. Age less than 12 for attending a painting class. Number of passengers less than or equal to 40 for the bus. Score greater than or equal to 50 for advancing in the competition. And weight less than or equal to 500 kilograms for the elevator. For sending a package via mail at a cost of $20, there are some constraints that we need to follow. First, the weight of the package must be less than 10 kilograms. Second, the circumference of the package must be greater than 50 centimeters and less than or equal to 100 centimeters. Let's translate these constraints into mathematical inequalities. For the first constraint, we need to represent the weight of the package. Let's use the variable weight to represent the weight of the package in kilograms. The condition says the weight must be less than 10 kilograms. In mathematical notation, we can write this as weight is less than 10 kilograms. For the second constraint, we need to represent the circumference of the package. Let's use the variable girth to represent the circumference in centimeters. The condition states that the circumference must be greater than 50 centimeters and less than or equal to 100 centimeters. This is a compound inequality which we can write as girth is greater than 50 centimeters and girth is less than or equal to 100 centimeters. We can write this more compactly as 50 centimeters is less than girth, which is less than or equal to 100 centimeters. Let's summarize the mathematical representation of our first example. If we denote the weight as weight in kilograms, we have weight is less than 10 kilograms. And if we denote the circumference as girth in centimeters, we have 50 centimeters is less than girth, which is less than or equal to 100 centimeters. Now, let's move on to our second example. This example is about the requirements for joining special forces. First, soldiers must have a height greater than 170 centimeters. Second, soldiers must have a weight greater than or equal to 65 kilograms and less than or equal to 100 kilograms. Let's translate these requirements into mathematical inequalities. For the first requirement, we need to represent the height of the soldiers. Let's use the variable height to represent the height in centimeters. The requirement states that the height must be greater than 170 centimeters. In mathematical notation, we can write this as height is greater than 170 centimeters. For the second requirement, we need to represent the weight of the soldiers. Let's use the variable weight to represent the weight in kilograms. The requirement states that the weight must be greater than or equal to 65 kilograms and less than or equal to 100 kilograms. This is another compound inequality which we can write as weight is greater than or equal to 65 kilograms, and weight is less than or equal to 100 kilograms. We can write this more compactly as 65 kilograms is less than or equal to weight, which is less than or equal to 100 kilograms. Let's summarize the mathematical representation of our second example. If we denote the height as height in centimeters, we have height is greater than 170 centimeters. And if we denote the weight as weight in kilograms, we have 65 kilograms is less than or equal to weight, which is less than or equal to 100 kilograms. In this video, we've learned how to express real-world constraints using mathematical inequalities. Let's recap what we've covered. We used inequality symbols like less than or equal to, greater than, and greater than or equal to represent constraints. We represented compound conditions using multiple inequalities or with compact double inequalities. We saw how to translate practical constraints from package delivery requirements and military recruitment criteria into precise mathematical language. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.